Good day to everyone who's watching. In our lesson 5 today of vectors, we are going to talk about the position vectors. These are vectors which originate from the origin. The position vectors, whenever I say they originate from the origin I mean the 0, 0 on the Cartesian plane, that is the y and x-axis having coordinates 0, 0. So if we consider this diagram here, I'm having my A and the B vectors that are originating from the origin, that is the OA and the OB. They come from the origin, and these are the ones we can call the position vectors. Now, to get my vector AB, it is like moving from point A, then reaching point B. So when we look at our diagram, you start moving from A towards O, then from O to B. So I'm having those two vectors there. But I know my AO is now the negative OA, because someone is changing the direction, the direction at first was from O to A, but now this person is going that side, then from there goes that way. So this one here, the change in direction, that is the negative. Then substituting here again, the AB is going to be equal to now my negative OA plus my OB, which I can rewrite as OB minus the OA. So we are going to be, in our examples, we are going to be employing such formula to solve our examples. My example 1, given position vectors, OP has that and the OQ has that. Calculate part A, the PQ. This one is going to be equal to the OQ minus the OP. So substituting the position vectors there, this is 5, 2 minus the 13, 17. So when I subtract negative 8, the negative 15. Part B, they're telling us to calculate the length of PQ. The length, we say it's the same as getting the magnitude. We have already got that vector PQ. And we say that this one is going to be equivalent to the square root of x squared plus y squared. So the x value here is negative 8. That is negative 8 squared plus the y value is negative 15 squared. When I square the 8, I get the 64 plus when I square the 15, I get the 225. When I add the 2, I get square root of 2, 8, 9. When I get the square root, I'm going to get 17 units. So example 2, given that my OA is 3, 7 and my vector AB is 5, negative 1, where O is the origin. Find the position vector of B, hence find its magnitude. Writing the AB, this one is going to be equal to the OB minus the OA. Then I substitute the vectors OA and AB, that is 5, negative 1, is equal to the OB I'm looking for, minus the 3, 7. Then this vector, I can take it the other side to remain with only the one that I don't have. So this is 5, negative 1, plus, because it was negative, 3, 7 is equal to the OB. Now my vector OB is going to be given when I add up 5 plus 3, I get 8, negative 1 plus 7, I get 6. That is my vector OB, position vector. Then they told us hence to find the magnitude of that vector. So my vector OB is going to be equal to the magnitude x squared plus y squared. Then I substitute, that is 8 squared plus 6 squared. When I square 8, I get the 64. When I square 6, I get the 36. When I add the 2, I get 100. Then when I get the square root, I get 10 units. So example 3, we have been given point N and the vector NM. Find the coordinates of M. So we are going to use that knowledge of position vectors. That is, to get my vector NM, I have to get my OM minus the ON. So I substitute the 4, negative 4 is equal to OM, the one I don't have, then minus this one here, I write it as negative 6, 8. Then I take it the other side, so this is 4, negative 4, then plus negative 6, 8 to give me my vector OM. So the OM finally becomes, when I add here, I get negative 2. When I add down there, I get a 4. So this is my vector OM, or the position vector of M, but the question wants the coordinates of M. So I come down and I conclude that coordinates of M are negative 2 and then a 1.